It is 2 a.m. on a Tuesday. A critical machine on the floor suddenly shudders, jams, and grinds to a halt. The line goes quiet. In many operations, the immediate reaction is to call the maintenance department and wait. There is a deeply ingrained belief that running the equipment is production's job and fixing it is the mechanic's job. But isolating the problem to the maintenance team ignores the actual economics of a failure. The physical repair, the parts, the labor, the time spent turning wrenches, is often the cheapest piece of the equation. This illustration shows the true toll of an unplanned breakdown. The heavy stack represents hidden costs, lost production, rushed repairs, collateral damage, and sudden safety risks. Set against the light weight of daily planned care, the math is clear. Unreliability is a massive expense. Because the sheer cost of a breakdown vastly outweighs the repair, the most reliable plants do not rely solely on heroic mechanics to put fires out. They rely on the frontline supervisors and operators to prevent the fires from starting. The people next to the machines every day are the ultimate first line of defense. They know exactly how equipment should sound, feel, and run. This charts the PF curve. There's a window between point P, where a fault is first detectable, and point F, where equipment fails. Catching it early relies on human senses. A new whine, radiating heat, or scorched oil are free data points gathered every shift. Spotting those signs and acting on them early in the window gives the frontline team control. It provides the time needed to schedule a cheap, planned repair on a quiet shift, entirely bypassing an expensive, chaotic breakdown. This active daily observation forms the basis of the cheapest and most effective maintenance strategy in existence: basic operator care. It is a protocol built on 3 simple habits, known as TLC. The TLC framework starts with tight and lubricated. Keeping bolts secure stops vibration, while proper oiling prevents frictional wear. The third pillar, clean, carries a strict rule. Cleaning is not housekeeping, it is an act of inspection. A layer of grime easily conceals a forming hairline crack. But when an operator wipes down a surface, they expose those hidden defects. By taking ownership of keeping machines tight, lubricated, and clean enough to inspect, operators remove the root causes of wear. They prevent a massive share of plant failures for almost zero cost. Of course, noticing a small leak or a new vibration is useless if it remains a passing grumble in the hallway. That observation has to enter the maintenance workflow. A vague complaint, like saying a pump is acting up, leaves a maintenance planner guessing. A specific notification, identifying the exact whining pump, pointing out the hot bearing, and noting worsening conditions, gives the planner the exact parts and urgency required. This diagram outlines how that accurate notification feeds the system. The frontline observation moves out of the identifying phase, triggering the planner to secure the parts and tools, and ultimately scheduling a highly targeted work order. This compares the same repair under 2 conditions. On the right, breakdown work is urgent, chaotic, and dangerous, with mounting costs. On the planned side, isolations are secure, tools are lined up, and the job costs a fraction of the price. The frontline supervisor's accurate reporting is the vital mechanism pushing work to the left side. It turns a potential crisis into a controlled, low-cost fix. The ultimate goal of this entire workflow is not to become incredibly fast at fixing machines. The goal is to need fewer fixes altogether. When a machine repeatedly misbehaves, it is very common for teams to blame the original engineering. They try to invent clever workarounds or redesign the equipment to stop the recurring symptom. Take a gearbox that continually pushes oil out of its seals. People will often say the machine is sweating. But a gearbox does not sweat. Heat builds up inside, and if the small breather valve at the top is blocked, the trapped pressure forces oil out through the easiest exit. If you keep changing the seals or try to re-engineer the housing, you will fail. The original designers built it correctly. By returning to the basics and simply clearing the blocked breather, you eliminate the actual root defect instead of repairing the same symptom over and over. This highlights a central rule of asset management: criticality. You cannot give every piece of equipment intense daily attention. Heavy effort must be aimed at the critical few machines whose failure would halt production, leaving a lighter touch for the trivial many. This bridge diagram connects those daily floor routines to a global strategy. The basic TLC care, The specific defect reporting and the focus on the critical few machines are all key components of the wider ISO 55000 asset management framework. Operations achieve reliability when operators and supervisors own the health of their equipment. By identifying the root causes of wear, reporting small defects early, and executing planned work on time, the frontline maintenance team becomes the absolute foundation of a world-class plant.